I'd like to spend a few minutes talking to you about electron configurations, which is a little bit of review from Chem 121, and jump into Lewis dot structure, as it's called, and some molecular structure. I put the electron configuration diagram on the board for the nitrogen atom. According to the periodic table, nitrogen is element 7. It has 7 total electrons, but we're looking at what are called outermost or valence electrons here. So down at the bottom of this, 2 electrons go into a 1s orbital. And like an apple where the seeds are in the middle, we call this the core. And so these are core electrons. They're towards the center of the atom, held tightly by the protons, and they don't do chemistry for us. We're not about to have these leave a nitrogen atom, and we're not going to have these dictate whether electrons come or go from the higher orbitals because of these. They're buried deep within the core. These are what are known as the outermost or valence electrons, and they dictate chemistry. 2 electrons go in the 2s orbital. These 3, following Hund's rule, go into separate 2p orbitals. Remember the 2p's? Your 2p orbitals are these peanut or dumbbell-shaped orbitals. There are 3 of them, up, down, left, right. And if I had a third arm, front and back. These all surround the nucleus. And electrons are in here. Now nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. And it's semi-stable. The 2p's are half filled. But compared to other things that this might come in contact with, this would be energetically stabilized if it obtained 3 more electrons. After all, nitrogen's a non-metal in the top right of the periodic table, and so gains electrons is its nature. It wants to gain 3 more. Well, it can gain 3 more, taking them away from sodium or calcium or something, and putting electrons into those 2p's to fill it up. Or it could share electrons by making a covalent bond. And that's what we're going to do with something called Lewis dot structures.